Alright, this is Tabatha Caskey. I'm doing our big numbers lab activity for physical science. I'm on number 7 and I'm going to measure the length and width of a $20 bill. The length looks to be as if it is 15.5 centimeters. So I'm going to write that down. And the width is 6.6 centimeters. Alright. Question 8 says, if you laid $48.5 million bills end to end, how many miles long would that trail be? Okay, so now we know that the length of $1 bill is 15.5 centimeters. And in every 1 inch, there's 2.54 centimeters. That, and in 1 yard there is 12 inches. There's 12 inches in 1 foot. Not yard. And then there is 3 feet. 1 yard, and then there is 1,760 yards in 1 mile. So the total across that top is 15.5 miles divided by 2.54 times 12 times 3 times 1,000. Equals 1.5 divided by 160934, and you get 2.54 times 12 times 3 and that in scientific notation would be 9.6 times 10 to the negative 1, 2, 3, 4th power, negative 4. And so, the answer is, if you laid those side by side, it would be 9.6 times 10 to the negative 4 miles. Oh, no, that's wrong. That's how many it would do for $1 bill. So then you want to take that answer, you want to times that by $48.5 million. So you do 0.5.6 times 4.5 power. And that's going to be 4,656 miles for $1 million dollar bills lined back to back. About how many times around the earth would the string reach if the string? I've done something wrong. I'm going to just stop it. Okay, so I got an answer of 46,560 miles. Now on 8B, it wants to know how many times this would go around the circumference of Earth. So I'm going to take 46,560 miles divided by 25,000 miles, and I'm going to see 46,560 divided by 25. That would be 1.8624 times. 1.864 times. How many square miles would the trail? Okay, so we're going to take, I'm going to square 46,560 miles squared is 46,560 is 215.778 square miles. Okay. Number 10 says, let's say you have 48 million, okay, and alright, so we're gonna do $48.5 million, and then 5 seconds is gonna be $10 and $10 out of a million will end up being .00001 million dollars per second, and there's 60 seconds and 1 minute. $60 minutes and 1 hour. There's 24 hours and 1 day. And there's 365 days in 1 year. Those cancel out, those cancel out, those, that. So I get an answer. So we're going to do $48.5 million times 5 equals 20 or 2 2.425 times 10 to the 8th power over 0.00. 1 times 60 seconds times 60 minutes times 24 hours, 365 days. Let's do 31536 and that's going to be 2.425 times 10 to the 8th power over 1. Okay, it's going to take 7, 6, 8, 9. It'll take 768,962 years for my unemployed buddy to count out loud my $48.5 million. And that is the end of this lab.